Okay, so this is just kind of a supplement to lesson 8.4 day 1. When you're dealing with rational expressions, one of the ways they're different than a fraction is you can have restrictions on the variables, and that comes from the fact that when you have a fraction, the bottom number, the denominator, cannot be 0, right? So as smart as, say, Mrs. Litchi is, if you ask her what 4 divided by 0 is, she will say, question mark, don't know, right? Because you can't take 4 things and put them in groups of 0. You'd have infinite number of groups, right? So when you're dealing with a fraction, you can't ever have 0 on the denominator. Okay, so with a rational expression, when you have these two expressions, the idea is that there's restrictions on x. For example, in this particular case, x cannot be -2. That's called a restriction. And that comes from the fact that if x were -2, this little expression would be -2 squared plus 5. So I think that'd be 9 over -2 plus 2. So we'd have 9 over 0, and then we'd have an error. All right, so a kind of a follow-up is when you're dealing with rational expressions, sometimes they'll ask you, are there any restrictions on the variable? And just think about, hey, what numbers for the variable will make the denominator come out as 0? Okay, so I'm just going to go through a few of the examples that we had here. Um, so any restrictions on this one, you basically want to know, again, when is the denominator 0? It's okay to have a 0 in the numerator, right? Like 0 divided by 3, nothing put into groups of 3, each group gets nothing, right? So that's okay, you just can't have 0 on the denominator. So the question really becomes, what numbers for x will make this denominator be 0? And you could just solve this straight up by adding 1 and then taking the square root of both sides. Would give you plus or minus 1, right? Or oftentimes I like to use factored form. So if I use this form over here and say, when is that 0? Sometimes that's easy. We have x plus 1 times x minus 1 equals 0. And we can use that 0 product property here, which says if something times something else is 0, either the first part has to be a 0 or the second part has to be 0. Right? So if a times b is 0, either the a has to be 0 or b has to be 0. So in this case, one of these little things has to be 0 if they multiply up to 0. So we could set x plus 1 to be 0 and x minus 1 to be 0. And that would give us the same two answers of x equals -1 and x equals 1. And again, those are called restrictions because they make the denominator 0. All right, and don't look at the ending answer when you're doing restrictions. Look at sort of the original question and say, what numbers for x would make that denominator 0? That will determine your restriction. So this one has 2. Okay, and then one other example from the homework. Any restrictions here, again, just look at what will make this denominator 0. And this is kind of hard to tell. X squared minus 3x minus 10, when is that 0? But if we go to the factored form over here, right? Once we've got it factored apart, it's easier to solve that quadratic because we can just say, okay, if they have to multiply up to 0, set x minus 5 to 0 and x plus 2 to 0. Okay, and then your two restrictions will be x5 when we solve the first one, and then x minus 2 when we solve the second one. Subtract 2 from both sides. So those are our restrictions on the variable. Again, we're just looking when is the denominator 0. Just a quick story about this. When I was a computer programmer, if you make a mistake, right, and try and divide by 0, you often get like errors. So if you ever had an app crash or a website crash or something, one of the reasons might be that the programmer forgot to worry about divide by 0, and you might get some weird error looking like this. But yeah, generally when you divide, you always have to watch for when is the denominator 0. And that's really what's going on here is there's restrictions on x because this whole expression in the bottom cannot be 0. Otherwise, it makes big time problems. Okay, I hope all of that helps.